3, 2, 1.
Hi, in this video of practical tips for rocket engineering, we're going to take a closer look at some of the fixtures and fittings that you might use, and specifically some of the connectors that you'll use as well. In the lab that I manage, okay, we exclusively use swage lock, okay? And the most common type of swage lock connectors that we'll use are swage lock compression fittings. You have the male end here, and you have the female end here. And what you're effectively doing is doing a compression fitting. So on the female side, you'll see a nice smooth surface that will become one part of the mating surface. And then on the inside surface of the male element, you also see a reciprocal smooth surface here. And what you're effectively doing is you're mating these two surfaces together, and then you're putting them under a compression load as you tighten up the fitting itself. Now when you tighten this fitting up, you don't need to tighten it all the way up so you can't see a missing gap. In fact, if you do that, you'll actually ruin the fittings inside. So all you have to do is tighten it up hand tight first, then get a spanner and crank it round half a turn until you get a good fitting there. But that compression is squeezing those two metal surfaces together and producing your sealing surfaces. So why would we use compression fittings in our feed system? Well, compression fittings are used when we want to connect two parts of our pipework and feed system together, and we're anticipating that they're not going to be disconnected too many times. So a fitting like this, on average, okay, will work 10, 15 times. They can actually work quite a lot of times, but good practice is that after 10 or 15 times you might want to replace them for a new compression fitting. Okay. The important thing is that you don't over tighten the fittings when doing so. So when you are doing up a compression fitting, okay, make sure that you are torquing them from both fittings, okay, and not just one fitting. Okay, so you put one spanner on one side, making sure that you've got good connection. Get your other spanner on the other element, on the other component, okay, and you're effectively counter twisting them against each other, okay? All right, don't be tempted just to torque on one system or the other, because you are effectively potentially loosening other parts of the fittings if this was a sub-assembly made of several connections together, okay? Or putting stresses on the fittings and on the tubing which aren't necessarily what they're able to cope with. So compression fittings, great for parts of your feed system or your rocketry where you're not disconnecting those systems too often and you're creating a semi-permanent infrastructure. So the next type of fitting that we're going to be looking at are VCR fittings. So VCR fittings, okay, look very different from your compression swage lock fittings, and they effectively have an edge to them. And the idea is that you have a seal which goes in between those two edges, and those two edges effectively bite, okay, into the softer metal, okay, which is in between, creating that really good gas seal. So the way that these operate, okay, is that you'll put the seal in a small little housing casing, pop it over one of the VCR connectors, okay, and then you will get the other connector in, just place it on loosely, okay, twist these two up, okay, and then you would torque these together to get the compression between the seal, bending the seal and stopping any gas flow leaks through. So VCR fittings are really good when you are dealing with connections which are regularly disconnected and connected with each other. So for instance, perhaps you've got a part of your feed system where you are disconnecting the main rocket engine to and from, and so having a VCR fitting there will be ideal in that case. The last type of connectors that we use in the lab that I manage are parallel threads and tapered thread connectors. We use these in two particular different areas. The first is when we are dealing with two different metal types. So, for instance, if we were trying to connect brass with stainless steel. Another time when we would use parallel thread or tapered thread fittings is when we are trying to connect our swage lock fittings into, let's say, the main bulkhead of the engine. So parallel thread fittings, you'll notice that the thread is all parallel with each other. Another common name for parallel threads, okay, are BSP fittings. The other type of connector is a tapered thread, and you can see that there is an ever so slight tapering to this thread, otherwise known as an NPT fitting. Hopefully that gives you a quick overview of some of the connectors that we use in our rocket lab and why we use them. So, if you like this video, please like and subscribe.